Hello everyone. Today we will see the simulation of monostable multivibrator. So the monostable multivibrator, it contains only one state, so that is a stable state. Now here 0 is nothing but stable state, and if you want to change monostable state from stable state to unstable state, we are going to provide trigger. Okay, so that is one difference between monostable and a stable multivibrator. In the stable multivibrator, we are not going to use a trigger, and in the case of monostable multivibrator, we are going to use trigger in order to change its state. And so in order to observe that output here, I connected LED. So let's see, once if you apply trigger, let's see how much time LED will on. Okay, so now let's see the pin configuration of monostable multivibrator. And here it contains 8 pins. Let's see the 2D view of 555 timer monostable multivibrator. You can see here pin number 1 is connected to ground. Pin number 2, that is, we are providing negative going trigger. So when switch is closed, I'm using switch. When this switch is closed, so the ground is applied to the pin number 2. That means a negative going signal is applied to the pin number 2. When switch is open, you can see through this resistor, it's again optional. This resistance is optional. Directly you can connect, or through resistance you can connect. So that means we are providing 5 volt is applied to the pin number 2. That means you just remember I explained the internal block diagram of monostable multivibrator. In that case, the trigger, it's a short pulse. Once if you apply trigger, the maximum value will going to drop. That means a negative going signal is applied. So when trigger pulse passes, then it will come back to its maximum value. What is the maximum value? 5 volt is nothing but maximum value here. Okay, this is pin number 2. Pin number 3 is nothing but output. I have connected LED here. Through resistance I have connected LED. This resistance is nothing but current limiting resistor. To protect LED, we are using this resistor. Then pin number 4 is always connected with VCC. It's a reset pin. It is always connected with a VCC. Pin number 5 is nothing but control. I have not connected anything to the pin number 5. If you want, you can connect one capacitance. Through capacitance you can ground pin number 5. It is not required. The control voltage is not required. We are not going to provide any control voltage. Pin number 6 is nothing but threshold, and pin number 7 is nothing but discharge. Okay, in the case of monostable multivibrator, these 2 pins are shorted together across capacitor. Okay, so now pin number 8 is nothing but VCC. It is connected to VCC. So this is the IC version of monostable multivibrator, and you can see here this is nothing but your charging circuit, charging and discharging circuit, and I have designed for around 22 milliseconds. I have designed. That means once if you apply trigger here, so this LED will turn on for 22 milliseconds. Now let's see. Let's see the 3D view, and you will see once if I apply trigger, you can observe. Yeah, you can see LED is on for a time, for a particular time, then it will turn off. Okay, once again I will press trigger. You can see LED is on. At that time you can observe the capacitance will charge, and when LED is off, immediately it will go into discharge. Okay, you can see. Please, once you check the waveform of capacitor, see, I'll just pause this. You can see the capacitance will charge through this particular resistance. Capacitance will going to charge up to VCC, and once this is off, immediately capacitance will go into discharge. So the capacitor will go into discharge through this particular pin. Okay, so this is all about monostable multivibrator. You can design for a for a different time. You can design. Usually we use the equation TP is equal to 1.1 into RA into C. So the TP is nothing but time duration. You can design for 1 second, you can design for 2 seconds, you can design for 5 seconds. So you should assume any one value. Either you assume capacitor value or you assume resistor value. So the equation is TP is equal to 1.1 RA into C. Use that equation and try to design monostable multivibrator. Okay, thank you.